Everyone thinks we can't go faster than light because the speed limit is absolute, like a law written into the fabric of reality. But that's not the real reason. The real reason is darker, more fundamental. Light doesn't travel at the speed of light because it's fast. Light travels at the speed of light because it has no choice. It's massless, and anything without mass must move at exactly that speed through space. Always. No exceptions. The speed limit isn't about velocity, it's about causality, about the structure of space-time itself. If you could go faster than light, you wouldn't just break physics, you'd break cause and effect. You'd be able to arrive before you left, kill your grandfather before he met your grandmother. The universe doesn't allow this, not because of some cosmic traffic law, because reality would collapse into paradox. If you're ready to understand why the speed of light is really the speed of causality, hit that subscribe button. The explanation starts now. Let's start with what everyone gets wrong. They call it the speed of light, but light isn't special. Photons aren't privileged particles that get to go faster than everything else. Light goes that fast because it has to, because it has zero mass. And zero mass means you don't get to sit still. You don't get to move slowly. You move at maximum speed through space, period. Here's the part that breaks most people's brains. Space-time isn't just space. It's space and time woven together. 4 dimensions. 3 of space, 1 of time. And everything in the universe is always moving through space-time at the same total speed. Always. You, me, a rock, a photon. All moving at the same rate through the combined fabric of space and time. But here's the trick. You can divide your motion between space and time. If you're sitting still in space, all your motion goes into time. You're moving through time at maximum rate. That's why time passes for you. 1 second per second. But if you start moving through space, you steal some of that motion from time. You move a little through space, a little less through time. The faster you go through space, the slower you move through time. This is time dilation. Not a metaphor, not an illusion. Actual physical time running slower for moving objects. Light moves through space at maximum speed, which means it uses all its motion for space. None left for time. Photons don't experience time. A photon emitted from a distant star billions of years ago doesn't age during its journey. From the photon's perspective, if it had one, it's created and absorbed in the same instant. No time passes, because all its motion went into space. Now here's why you can't do the same thing. You have mass. Mass creates a connection to the time dimension. It roots you in the flow of time. You can move through space, but you can't give up time completely. You're anchored. The more mass you have, the stronger the anchor. To move faster through space, you need energy. And as you add energy to something with mass, it gets harder to accelerate. Not because the object gets heavier in the normal sense, but because the energy itself has inertia. The faster you go, the more energy it takes to go even faster. Exponentially more. Do the math and you find that to accelerate something with mass to the speed of light, you'd need infinite energy. Not a lot of energy. Not more energy than exists in the universe. Literally, infinite. Which means it's impossible. Not impossible like building a space elevator is hard. Impossible like dividing by 0. The equation breaks. The concept stops making sense. But here's the real kicker. The speed limit isn't really about energy. It's about something deeper. Let's talk about what would happen if you could go faster than light. Forget how. Pretend you have a magic spaceship that can accelerate past the light barrier. You point it at a star 10 light years away and hit the gas. You go twice the speed of light. You arrive in 5 years instead of 10. Sounds fine. Sounds like you just saved time. But from another perspective, from someone watching you from a different reference frame, you didn't save time. You went backward in time. You arrived before you left. This isn't science fiction. This is what Einstein's equations say. The math is clear. If you move faster than light in one reference frame, you're moving backward in time in another. Here's why. Simultaneity is relative. Two events that happen at the same time for you might not happen at the same time for someone moving relative to you. This is already proven. GPS satellites have to account for this. Time runs differently on a satellite moving at 8,000 miles per hour than it does on the ground. The difference is tiny, nanoseconds per day. But it's real. If GPS didn't correct for it, your navigation would drift miles off course within hours. Now scale that up. If you're moving at 90% the speed of light relative to someone else, events that are simultaneous for you are separated by years for them. If you're moving faster than light, the separation goes negative. An event in your future becomes an event in their past. You can send a signal that arrives before it was sent. From the perspective of different observers moving at different speeds, cause and effect flip. This creates paradoxes, real ones, not philosophical puzzles, physical contradictions. Imagine you send a faster-than-light message to a distant spaceship. The spaceship receives it and sends a reply back faster than light. From your perspective, you sent a message and got a reply. Normal. But from another observer, when moving at high speed relative to you, the reply was sent before your original message. They see the answer before the question. Reverse causality. Push it further. You get in your faster-than-light ship and fly to a star 10 light years away. You arrive in 5 years, turn around and fly back. Another 5 years. You return 10 years after you left by your clock. But because of the way relativity works with faster-than-light travel, you can arrive home before you left. You meet your past self. You could stop yourself from leaving. But if you stop yourself, you never made the trip. So you can't stop yourself. Paradox. The grandfather paradox is the famous version. Go back in time and kill your grandfather before he has kids. Then you're never born. But if you're never born, you can't go back in time to kill him. So he lives and you're born. But then you go back and kill him. Loop forever. Contradiction. Reality doesn't know which timeline to pick because both lead to the other. The universe doesn't allow this. Not because it has rules about time travel, but because the structure of space-time itself forbids it. The speed of light isn't a speed limit, it's the speed of causality. The rate at which cause and effect propagate through the universe. You can't go faster than causality because causality is what makes reality coherent. Break it and you don't get time travel, you get nonsense. Okay, fine, paradoxes are bad, but why physically can't we accelerate to light speed? Why does the math break? Let's get into the mechanics. Einstein's special relativity gives us an equation. The energy of an object equals its rest mass times the speed of light squared divided by the square root of 1 minus the velocity squared divided by the speed of light squared. When velocity is 0, this simplifies to the famous E equals mc squared. But when velocity increases, that denominator gets smaller. The square root of something less than 1. As you approach the speed of light, the denominator approaches 0, which means the total energy approaches infinity. Not a huge number, infinity. To actually reach light speed, you'd need infinite energy. Can't be done. The universe doesn't have infinite energy, and even if it did, the process doesn't converge. The closer you get to light speed, the more energy you need to get even closer. It's asymptotic. You can get to 99%, then 99.9%, then 99.99%, but you never reach 100. Now here's why. Mass isn't just a property of matter. It's resistance to acceleration. It's inertia. When you push on something, it pushes back. That pushback is mass. Massless particles like photons don't push back. They don't resist. They just move at light speed, always. But anything with mass resists. The more mass, the more resistance. And as you add energy to accelerate something, that energy becomes part of the object's inertia. It adds to the effective mass. So the faster you go, the harder it gets to go faster. Not because friction, because the energy you're adding is itself resisting further acceleration. Particle accelerators prove this. The Large Hadron Collider accelerates protons to 99.999991% of the speed of light. Insanely close, but not quite there. And to get them that fast, it takes the energy equivalent of a freight train moving at 100 miles per hour for a single proton. To get one more decimal place closer, you'd need exponentially more energy. To actually reach light speed? Infinite. Experiments confirm this every day. The closer particles get to light speed, the harder they are to push, exactly as relativity predicts. This isn't a limitation of our technology. It's a feature of reality. Mass and light speed are incompatible. You can have one or the other, not both. Photons have zero mass and move at light speed. Electrons have mass and can't. You can't cheat this by adding more fuel. You can't engineer around it. The universe says no. But wait, what about wormholes? What about warp drives? Alcubierre drives? These are theoretical ways to travel faster than light without actually moving through space faster than light. A warp drive bends space-time around a ship. Space in front contracts, space behind expands, and the ship rides the wave. Technically, the ship isn't moving through space faster than light. Space itself is moving, so no paradox. Right? Wrong. The math works in general relativity, but it requires something called exotic matter, matter with negative mass, which probably doesn't exist. Even if it does, you'd need more of it than exists in the observable universe. And even if you could gather that much, the energy requirements are so extreme that the process would create a black hole, which would swallow the ship. Warp drives aren't forbidden by physics. They're just impossible for any civilization bound by thermodynamics and the reality of matter. Wormholes have similar problems. Yes, general relativity allows shortcuts through spacetime, tunnels connecting distant points, but keeping a wormhole open requires exotic matter too. Without it, the wormhole collapses instantly. Even if you stabilize it, crossing through might not be survivable. The tidal forces could be lethal. And there's the causality problem again. A stable, traversable wormhole is mathematically equivalent to a time machine, which brings back all the paradoxes we're trying to avoid. So we're stuck. The speed of light is absolute, not because physics is mean, because reality is structured this way. Causality propagates at light speed. Information can't travel faster. Cause and effect are bound by this limit. Break it, and you break logic itself. What does this mean for exploring the universe? It means interstellar travel is hard, really hard. The nearest star system, Alpha Centauri, is 4.37 light-years away. Even if we could build a ship that goes 10% light speed, which we can't, the trip would take 43 years, one way. The travelers would age 43 years, everyone they left behind would age 43 years. No shortcuts, no cheats. At higher speeds, time dilation helps. If you accelerate to 90% light speed, time slows down for you by a factor of about 2. A 10-year journey for you is 20 years for people back home. At 99%, the factor is 7. At 99.9%, it's 22. You could cross the galaxy in a human lifetime, from your perspective, but centuries would pass on Earth. This creates a one-way door. Leave on an interstellar voyage at near light speed, and everyone you know will be dead when you return. Your family, your friends, the entire civilization you left behind might have risen and fallen. You become unstuck in time, a traveler from the past arriving in a future you can't predict. Some people see this as romantic. Most see it as tragic. But there's another option: generation ships. Build a vessel large enough to support a population for centuries. Accelerate slowly to avoid crushing everyone. Coast for decades or centuries. Decelerate slowly. Arrive at the destination and colonize. The people who left Earth won't see the new world. Their great-great-great-great-grandchildren will. The journey becomes the life. The ship becomes the world. You're not traveling to a destination, you're migrating. Building a new branch of humanity that splits from the old.
Or we accept that interstellar travel isn't for humans. It's for machines, probes, self-replicating robots that don't age, don't need life support, can wait centuries between stars without suffering. We send them out to explore, to build, to prepare colonies for human arrival later if we figure out suspended animation or generation ships. The universe becomes knowable, but not reachable in a single human lifetime. This is the price of causality. The universe is big. Information takes time to cross it. We're locked into our local region by the speed of causality. We can see distant galaxies, but we can't touch them. We can send signals, but conversations take years. If we detect alien civilizations on planets 1,000 light-years away, our hello takes 1,000 years to arrive. Their reply takes another 1,000 years. A simple exchange spans 2,000 years, longer than recorded human history. Some physicists wonder if there's a loophole. Quantum entanglement lets particles stay connected across distances. Change one, and the other changes instantly, faster than light. But you can't use this to send information. The changes are random. You can't encode a message. When you measure an entangled particle, you collapse the connection. It's like having a pair of magic coins that always land on opposite sides. Flip yours and you know what the other shows, but you can't control what it shows. So you can't send a signal. Entanglement is spooky, but it doesn't break causality. There might be physics we don't know yet, deeper layers, new forces, something that allows faster-than-light communication without paradox, but we haven't found it. And the more we test relativity, the more solid it becomes. Time dilation confirmed by atomic clocks on airplanes. Length contraction confirmed in particle accelerators. Gravitational waves moving at exactly light speed confirmed by LIGO. Every test says the same thing. Light speed is the limit, not just for light, for everything. The universe is telling us something. Reality has a speed. Causality has a speed. You can't outrun your own cause and effect. You can't arrive before you left. You can't send a signal faster than the signal's existence can propagate. This isn't a flaw in the design. It's what makes the design work. Without this limit, nothing would be stable. No past, no future, no coherent timeline. Just chaos. We're not locked in a cage. We're protected by a fundamental truth. The universe makes sense because causality flows forward, because causes precede effects, because information takes time to spread. This is the foundation of everything. From chemistry to consciousness, from stars forming to civilizations rising, all of it depends on the arrow of time, on causality, on the speed of light being what it is. The real reason we can't travel faster than light isn't about speed. It's about causality. Light moves at light speed because it has no mass, no anchor to time. It gives all its motion to space. We have mass. We're rooted in time. We can't escape it. And if we could, we'd break cause and effect. We'd create paradoxes that unravel reality. The speed limit isn't a law we obey, it's the structure we exist within. Break it, and you don't get superpowers. You get nonsense. This is why interstellar travel is hard. Why the universe is vast and lonely. Why we're bound to our local region by the speed of causality. But it's also why reality works. Why physics is consistent. Why we can make predictions and build technology. The speed of light is the price we pay for a universe that makes sense. If this video changed how you see the speed limit, hit that like button and subscribe to Space and Scale. Next time we're exploring what's outside the observable universe, and the answer is stranger than you think. See you there.